Hello. So this is my elementary statistics final project by, of course, me. So the objective of this is to recognize whether or not activities outside of school affected a student's ability to achieve good grades. So the tools used besides StatCrunch were 6 quantitative questions, 3 qualitative questions, and 2 binary questions. I know 6 quantitative questions seems like a lot, but you'll see where I tie them in together. The questions asked explore factors like age, working hours, working days, and hours on other activities. When I say hours on other activities, it was just mainly just exercising. So how many hours they spent exercising a day or a week, sorry. There's also mention of grade point average, studying habits, and classes taken this semester. One thing I would like also to add is I also ask questions about overall mood. So, like questions like, is your sleeping schedule consistent, or if you're feeling anxious some days? So, the quantitative questions asked were, what is your age? How many hours do you spend studying? How many hours do you work a week? How many hours do you spend exercising? What is your grade point average? And how many classes are you taking this semester? So these questions will be useful in considering habits of students and how it affects them with certain factors. The qualitative questions asked were, how many days do you spend working? How many days do you spend studying? Do you prefer studying at home or school? These questions will help us identify studying and working habits of students. And the 2 binary questions asked were, do you feel anxious some days? And is your sleeping schedule consistent? So these 2 questions will assist us with trying to figure out the overall mood of students. So, like everything, I did run into some problems. So this was like, for the most part, the only data set that gave me some problems or mishaps. While cleaning it, we can see that some students put a letter grade instead of numerical. So you can see that we have a B, or even some students didn't know their grade point average. This made it a little bit more difficult to exactly pinpoint the correct grades of students. And this is my data used. So you can see all the questions I asked, how many people were surveyed. Um, yeah, it's all cleaned up, which I made sure of. So I'm starting off with my hypothesis. So in word form, my null hypothesis was all students performed the same in class. And my alternative hypothesis was active students performed lower than non-active students. What this means was students that worked or students that did other activities just didn't do as well as other students. And in statistical form, this is how I put it. And our significance level I chose was 0.05. Alright, let's take a look at this data. So we have 2 graphs here. The one on the left is hours a week working, and the one on the right is hours a week working. Sorry, on the left is hours a week studying, and the right, hours a week working. So as we can see, the hours a week studying follows a normal distribution. I say normal distribution only, I feel like, because the 10 right there really helped it. If not, if we didn't have that 10 plus hours studying, then this would definitely be more right skewing. But for the most part, I think it's a normal distribution. And hours a week working just didn't follow that normal distribution. It is definitely more left skewing, with more students not working so much, or like working 0 hours a week. So, what does this mean? When comparing the two histograms, we can see that there are more students studying for longer periods of time than students working the longer shifts per week. But when we dig deeper, we can see the true means of these with this summary statistic. So the true means are 7 and 12. And then it also shows our end value, so that just basically means how many people were surveyed. How many, yeah, people were surveyed. Our sample size, there you go. And the median is literally almost the exact same as the mean. So this must mean 7 and 12 are like the average of what people were studying and working. So we can see that compared to the graphs, right? That, like, I thought more people were studying than working. We can see that there was actually more people working than studying because of this mean right here. So this contingency table is just to show the frequency of how many days people were working. It's just to get a broader scope of the habits. Um, so here we see the rows are days spent working, and the columns are days spent studying. So in my first opinion was, you know, if if there if there was a lot of people not working any hours, I would think they'd be studying every day. But that does not seem to be the that doesn't seem to be correct, because where there are people not working any shifts or anything or any hours per week, it was only two studying every day. And looks like two people studying every day and working every day is pretty interesting. Oh yeah, and then I just want to point this out. I do have an error in here. It's just, I accidentally put 7 days instead of every day, but it just, I don't think it affects it. It shouldn't affect it. All right, let's head into students' mood. So we can see the two pie charts of consistent sleeping schedule and feeling anxious most days. Big, big, big difference. Um, we can see which answer was answered more. Okay, estimating parameters on feeling anxious most days. So for this one, I did a confidence interval of 95%. So the number of successes being 30 and the number observed being 33 just means for this one I chose it, yes being number of successes. Yes, people felt anxious most days, and the observed was obviously the 33 sample size. So we have our lower and upper limit. The lower limit being 0.811 and the upper limit being 1.007. If we put this in our parentheses, it'd be 81.1 being the lower limit and 100.7 being the upper limit. What this means is we are 95% confident that the true proportion is within the value is it within the range of these value numbers? So it just means 81 to 100% of people, or sorry, students felt anxious most days. All right, getting into a look of correlation. Um, sorry, let me go back. So I wanted to mention this. I feel like since we see a lot of people not having a consistent sleeping schedule, it could be that their overall mood of feeling anxious does affect that. If you don't, obviously, if you don't get enough sleep, you just don't feel your best, and you're obviously not gonna do your best. You know you're gonna be feeling anxious. But obviously in StatCrunch, or I couldn't find a way in StatCrunch to input that. It was more numerical to do like correlation. And now going into correlation. So for this uh, correlation test, I did hours a week working and hours a week studying. So this data set was the best fitting for a correlation graph. It, as we can see, the linear line follows a negative trend, which means our value is going to be negative, which is negative 0.250262124. So what this means is it's obviously going to be a weak correlation because so I think it's the R value goes from 1 to negative 1 or negative 1 to 1. And so this is obviously closer to 0. So it's just a weak correlation. And then even without knowing the R value or anything, we can see that the dots itself, they don't come close together by that linear line. Um, so it's a weak correlation by that too, without the R value being there. We do have some outliers, as you can see, which did affect the data. But I feel like if we did have a bigger sample size, it's still gonna be most likely. I feel like it would be actually might be a little bit closer together if we did have a bigger sample size without those outliers. But anyways, let's go on. All right, I wanted to add grade point average in here because I wanted you to see the mean. So the mean being 3.3, we have to take this into consideration for the hypothesis testing. But for the most part, it seemed like students performed well. All right, now for our test statistic. So for this one, I used the proportion for grade point average above 3.3 and students working. So what that means, basically, what I inputted into the system, I think it was, I think the 16 was students that were 3.3 and above. I put into there, and then 19 students were working, or it was the other way around. I can't really remember. So our z statistic being negative 3.3, I just rounded that, and our p-value of 0.009. I did change the 0.5 because that's what I did for my hypothesis. I'm honestly not too sure if that affected our z statistic and our p-value, which it could have, but I think that was what was appropriate because that's what my hypothesis was. So what does this mean? So since the p-value is lower than the significance level of 0.05 and the test of 0.5, we reject the null hypothesis and accept the alternative hypothesis, which is that students that are active perform lower than non-active students. All right, And this is my conclusion. Um, as you see throughout the slides, it seemed like some of the data was irrelevant to what I to the cause. But I feel like it was useful to get the feel for data, to get the feel for like cleaning up the data, correlation and error, like trial and error, of course. I did on other assignments try to use it, but the ones that are in here are best fitting, of course. Data like age, where people like to study, and exercising habits weren't used, but they were useful to know throughout the semester. Uh, because it gave me more. I feel like it opened the door to more options to what I could use in my data. Okay, and that's the end of it. But all I could say is, this was a very interesting project. Um, I hope to hear back from you, Professor, because I want to know where, if I did it right or wrong, and I hope I could learn from this. Um, but I did the best to my ability and what I got from the course. And all right, and that's it. Thank you.